This is 5.1.3, part H. We're told that X is normally distributed with a mean of 10 and a variance of 2. So if I was to write this over here, that tells me my mean equals 10, my variance equals 2, and so my standard deviation is going to be the square root of 2. Just so I kind of have that. Okay, now part H tells me the value of X. I'm supposed to find the value of little x for which the probability of the absolute value of X minus 10 is greater than or equal to that little x equals 0.63. Now this one looks far worse than it is, and you'd probably think yourself in circles without this little trick. So what we're trying to do is we're trying to figure out what this little x should be so that the probability of something, okay, let's not worry about what that is yet, something is greater than or equal to two numbers will be 0.63. Well, when you look at inequalities, if you want the absolute value is greater than or equal to, that actually means that you're looking for the tails. So it means like if I was to look at the standard normal table, I'm going to have a positive z value and a negative z value. And I'm trying to figure out the area in the tails, or trying to figure out what x value will, eventually I want to figure out which x value will give me 0.63 area in the tails. So 0.63 area in tails. Okay, I know that because like if I was back in a math class and I wanted the absolute value of x is greater than or equal to 3, well that means x is less than or equal to negative 3, or x is greater than or equal to positive 3. So if you don't remember this, look up inequalities with absolute values online and you can find some videos on it. But when you have absolute value greater than or equal to, that means you're going to be looking in the tails. So if I want 0.63 area in the tails, I would divide this by 2 and I'd get 0.315 area in the right tail, 0.315 area in the left tail. And if I was to look up a z value, because I already have the probability and so I know I'm going to be working backwards, so I'm going to be looking for a z value, and I want 0.315 area in the left tail. It looks like the closest I can get here is negative 0.48. So we can have negative z equals negative 0.48, or a positive z value of z equals 0.48. So basically we figured out the z value that will give you 0.63 area in both tails will be 0.48. But we kind of have to go back to this x value because they didn't want us to just get to z. Our goal is to get back to x. But the problem is we have this weird inequality. Okay. So let's kind of forget about the inequality or the absolute value for a minute. What if I just write like x minus 10 greater or equal to some little x value? Okay. Well, notice this x minus 10 might look kind of familiar because anytime you find a z value, you're going to do x minus the average over the standard deviation. So in our case, sorry, I'm using words. I'm stuck in the mindset of my other class where we use words. We use symbols in this class, but it'll work. X minus our average, which our mean was 10, divided by our standard deviation, which is the square root of 2. Notice how this x minus 10 looks a lot like this, x minus 10. So if I divide both sides by the square root of 2, okay, I can do the probability of x minus 10 over square root of 2 is greater than or equal to x over 2. Okay, so we're getting closer. So now this whole x minus 10 over square root of 2, that could just be replaced by a big Z. So capital Z greater than or equal to x over square root of 2. Now, again, I said we kind of forget about absolute values. We were technically supposed to have absolute values there is equal to 0.63. So basically, it's saying what z value that you could find both tails equals 0.63. Because we changed from x minus 10 to x minus 10 over square root of 2, and that became then just a z value. So now this whole thing is supposed to just be a z value that both tails will give you an area of 0.63. So this would have been a much harder problem if it hadn't just been 10. They wanted you to recognize x minus 10. Oh, that seems like what it would be if I was finding a z value for something in this problem. And then you could just divide by square root of 2 to finish standardizing. So what z-value had 0.63 in both tails? Well, we already found that. That's z equals 0.48. So let's say x over square root of 2. Let's set that equal to 0.48 because we know that 0.48 is what should be in that spot because that's what would make it work. So then if we just solve this, x is going to be 0.48 times the square root of 2. And we get 0.678. Now the textbook used a calculator to look up a z-value instead of the table, so they got 0.482, which puts them at their 0.6812 answer that they had. But this is the answer to x. So it wasn't so much like trying to manipulate this x minus 10 or like solve equations later. It was manipulate this random variable into the random variable z and then find the z-value that should go there and solve.